Alright, so we have an Atari 2600. The seller said it was broken. I have no idea whether it is or it didn't because I don't have the end to go on that. So what I'm going to do is I'm going to just take some coax cable and solder the coax cable directly into this and then plug that into my TV and see if I can get it to tune. And then once we do that, if I can figure out how to do that, we're going to go ahead and we're going to test it. So this thing cannot be difficult to take apart. Oh, this should be pretty simple then. Let me zoom in here. So as you can see, this piece right here should just unplug. And there we go. So then my plan of attack is going to be see if I can basically just solder. Just going to take some coax cable. If the center pin's hot, man, there is no way this sucker is going to work here. I want to find the center of this coax, and it looks like it's right here. So that's my center pin, and that's the ground, and that should be ground to those outer pins. All right, so that's going to be the plan of attack. Get some coax cable, strip it back, solder ground and solder hot, and somehow keep this from shorting out. So that's going to be the idea. All right, so let's cut the end of this off. We'll get a box cutter out and strip this back some. Alright, so that's what we have. So we are going to attempt to solder that to my plug and hopefully not short anything out in the process. So alright, that should be good enough to test. I got it all set up. So now I'm going to go ahead and insert our game. We're going to apply power, and it does that. Let me change the channel. It does that. Alright, so before I clean the cartridge, I'm gonna give this other game a try. Spider Fighter. So I'm gonna cut it on, and lo and behold, so it turns out there's nothing wrong with this Atari. So this will be a good candidate for an AV mod of some sort. Alright, so I think I need to take this outer metal shield off. So it looks like it's just held on with these twisty little pieces of metal. And I should be able to, looks like somebody already took some of these off. So that just pops right off. So I think for this piece, what I'm going to do is I am going to put these in some vinegar to maybe get some of that rust off of there. Can't leave it in vinegar for too long though, because it will eat all the nickel plating off, and I don't know how to nickel plate. So my intent for what I want to do with this is, I know it works, but I don't want to use the coax output to the TV. I don't want to use this RF modulator located here. So my intent is to figure out where the video and the audio signals originate before they go into the RF modulator. And then if I can pick those signals off, I could just run video out as the yellow plug, and then audio. I don't know if this has stereo or it's just mono, but I'll have audio coming out as well on either the white or red plugs, or maybe I can tie them together. So that's going to be the plan. Alright, so I'm going to talk about some of the things I've learned about an Atari 2600, but please keep in mind that I am not an electrical engineer, and this information may be wrong. So the Atari 2600 is a computer, a very old one, but it's a computer like any other, and it has a CPU, it has RAM, and it also has a device called a TIA, and that stands for a television interface adapter. And so essentially what happens is when I plug a cartridge into the cartridge slot, the CPU fetches information, or fetches instructions as it were, from the cartridge slot. And then it sends instructions to the telephone interface adapter, what colors to produce, etc. And that's the whole function of the telephone interface adapter. So it produces signals that I'm concerned with. It produces a luminescence signal, and we'll call that L0, L1, L2, and it also produces a sync signal. The luminescent signals control the actual brightness as far as what I've read. And the sync signal, it tells the TV basically when a frame starts and when a frame ends, so that the TV knows how to write or display what it's trying to display. The TIA also produces an audio signal, and it also produces a color signal, or chroma. They call it chroma, but it just means color. And what ends up happening in the Atari 2600 is all of these signals at some point are combined, essentially, maybe not necessarily combined, maybe the wrong word, but the presence of those signals is all felt at the same point, and that leads into, and these three signals are also felt. And in reality, what you have four different signals that will all form to become a luma signal, essentially. And all of those signals are fed into the RF modulator. And then that RF modulator does exactly what its name suggests. It takes an RF, or it takes a signal, and it modulates that signal onto an RF carrier. So the idea here is to figure out, if I can pluck these signals, if I can pluck the audio signal and the luminescent signals and the chroma signals. And so my thought process is I can take the chroma signal and I can take my luminescent signal and I can combine them into one signal and feed that out on a video out on the yellow port of an AV cable. And then my audio, I don't know if this again is stereo or mono, but I should be able to take my audio signal, pluck it out before it's amplified, and send that to my TV. So the other thing I have figured out is that there are a few different types of mods. There is one mod, and I ordered this mod last night. I wanted the little barrel connectors so that I could drill holes into the side of the case and run out the wires. But anyhow, there's one mod that looks like it simply takes these signals here and then amplifies those signals and sends that out on the video line. So that's one type of mod. It's just an amplifier, and I'm sure there are others. Please. I'm sure there's some geniuses out there. But there's one, so this one is an amplifier for your Luma signals. And then you do the same thing. You pluck out your audio, or it might be for Luma and Chroma. Not altogether certain. I didn't actually dig into their mod to try and figure it out. But then there's another type of mod that actually takes and outputs your Luma and your sync signals and puts them into an actual buffer, which from what I read, I think it's a CD 4050 or something like that. It's an actual buffer, and it produces a much crisper, clearer picture. So I guess the idea is, so when you go on eBay or whatever and you look, you see this might be a $10 mod, whereas this might be a $30 mod, because not only are you adding an amplifier for your Luma, your Chroma, you're also buffering that before you send that to the TV. Anyhow, I ordered this mod, so I'll be applying that when it comes in. But today, I want to try and pick off my Luma signal, combine that with my Chroma, and send that out across my yellow lead for video. And then I want to pluck off audio and then tie that to both my, if it's not stereo, and again, I don't know if it is. If it's not stereo, it's mono, I'm going to run those in parallel and split that audio signal and send it to the red wire and the white wire, so that we'll pretend that it's stereo. And then the only thing I don't know about is where to pick the audio signal, and if the Luma signals, I'm assuming they created an amplifier because these aren't powerful enough to maybe power a TV. I'm going to try it, and I'll probably remove the RF modulator to remove any type of load off of these signals. And essentially a load is just something that dissipates energy. Like when you go to measure resistance in your multimeter, you see the OL and it says an open load. So if I had a battery and that battery was connected to a resistor and I was coming off of that resistor, this resistor is my R sub L, my load resistor. Much in the same way, this RF modulator is the load for the TIA circuitry. It's what loads it down. So if I remove that, maybe I won't diminish the Luma and the Chroma signals as much. Anyhow, so the next thing we'll do is we'll pull open a schematic that I found and we'll look at that.
Alright, so I found this schematic on the internet, and I don't know if this is the exact model. I have a revision 9 motherboard, so I'm not sure. But anyhow, this shows the TIA. And we can find some of the signals that we're looking for. So first is audio. Then I have my color or chroma signal. And then down here I have my LM0, LM1, LM2, and my sync signal. So the idea is to pick a spot on my audio to pull off. And I don't know why it has 2 coming out, but anyhow, to pick a spot before it's amplified. And I think that Q201 actually amplifies your audio. So my audio follows this path, and when it gets to this point, because that transistor is there, I don't know. Again, I really don't know. But I know most times transistors are amplifiers or switches, so to speak, but this one's not tied to ground, so it's not a switch, so I'm assuming it's an amplifier. But anyhow, so I think I'll try to find R206, and that's where I'll tap into my audio. Chroma, is chroma strong enough? So all of these signals right here end up terminating right here at the top of R222, so I wonder, and that's right before they go into the RF module. And I wonder if I were to solder my yellow video cable there and my audio to this point right here, I wonder if that would provide me both audio and video. But again, these signals all go through resistors. As you can see here, in resistors, well, they resist. So they will drop voltage off of the signal. So by the time it gets here, is it going to be strong enough? Because I'm assuming in RF module, there's probably some sort of amplification that took place before it placed it on the RF carrier. But anyhow, so that is what we're going to try to do.
So now that we've removed the RF modulator, I want to figure out which of these pins is ground. Alright, so this is pin 1. So pin 1 is ground. Now let's go from R222, which I believe this was the input to the old RF modulator. So that's pin 4 then. So we should be able to connect the yellow wire to pin 4. So let us attempt to do that. Alright, we have video hooked up, so I'm going to test it with video first, and then if that works, then we will test it with audio. Alright, so I hooked up just the video. I've got it plugged in, so we're going to go ahead and cut it on and see what the TV does. I have it plugged just into the yellow, the video input to the TV. I don't know if you can see that or not, but it's very, very, very faint, very weak signal apparently. So I'm going to have to think about this some more and see if there's a better place to pull that signal from, but I think I'm on the right track. So what I'm doing now is I opened up the modulator and I found a 3906 transistor, which is a PNP. So I'm attempting to do this, but I'm getting confused, but I'm trying to essentially make an amplifier with that PNP transistor. Obviously on a PNP transistor, the base voltage has to be lower than the emitter voltage. And so coming out of pin 3, I have 5 volts. And that 5 volts, I've got it going through a 3K resistor going to the base. Then what I have to do is I have to come out of pin 4 and I have to go to the base, because that's going to be my signal input. On the emitter of that transistor, I'm going to have a smaller resistor tied to the 5 volts than what I have on the collector. So essentially I'm going to have like a 90 ohm resistor on the emitter, and I'm going to have like a 300 ohm resistor on the collector. And because I have a 3K going to the base, that should forward bias that transistor and allow it to amplify. I don't know how much it's going to amplify. Probably not a lot, since I'm using fairly large resistor values. But now I'm trying to figure out which one of these is the base, or I know this is the base, but which one of these is the emitter. So I've got my multimeter in diode mode, and I'm going from the base to there, and it says 0.74. So if I go from here to the other lead, I'm getting the exact same reading. So which one of these is and it's obviously open load, which is it's supposed to be. So which one of these is the emitter? So that's 0.740, and that's 0.745. So I am going to say, since the larger voltage drop should be across the base to emitter junction, I'm going to say this is the emitter. And then what I'm going to do is I'm going to take my 90 ohm resistor and I'm going to tie one end to 5 volts and the other end I'm going to tie to the emitter. So which one of these is the 90 ohm resistor? That's kind of on there. So now I need to run a wire from there to the 5 volts. So let me find this wire. So that looked like it took. So I think that I'm going to fold this down and tie into the 5 volts on the bottom. The bigger the blob, the better the job. That's what they say. So I think that's on there. That looks pretty good. Doesn't look like anything's shorting out. So now I need to have a wire that comes out and connects from pin 4, which is Luma, audio, and all of those. I should probably break that audio circuit too, because I don't want audio amplified. So not that I know this is going to amplify, because I most certainly do not know that. I'm just hoping it doesn't catch on fire or blow up my TV. That's what I'm hoping. Maybe that's on there. So now I'm going to take some solder and put on pin 4 here, and then I'm going to affix that cable to that. Alright, so let's review what we have here. So we have pin 4, which is Luma Chroma, and currently audio, going to the base of that transistor. On the emitter of that transistor, I have 5 volts going through a 98 ohm resistor, which will apply voltage to the emitter. It'll apply more voltage to the emitter than that will be felt on the base, which should forward bias this transistor, and which should give me an output from the collector. But what I have to do now is I have to somehow take a piece of wire. This is going to be hard. Take a piece of wire. I'm going to wrap it together. like so. I'm going to tin both ends of these. What I'm going to do is I'm going to take this resistor and I'm going to wrap it around I just realized something. I should have done that to the other side too, because the other end of this resistor has to go to ground. Okay, well, let's grab another piece of wire and try to do this while it's sitting there without destroying everything. Alright, that's ground. Let's try to get this transistor back on here. I might have to put this under the microscope to do this because I can't see. So I think I got it on there. So the last step is, this is going to be my output. So essentially I need to take my one end of this has to go to ground and the other end of this has to be tied. Alright, so that's good, I think. So the last step in this is to take this, tin it, don't fall off, bud, don't fall off, come on man, and this wire, and connect this wire to this wire. Man, that is, oh my goodness, this thing is going to blow up. It is going to blow up as soon as I plug it in. I got to figure out what the audio circuit is and remove the audio circuit. So that's C208 or R208, I guess. Of course, I can't see. So the audio comes out and it goes through R209. So that means that R209, one side of it should go to pin 4. All right, so all I really have to do then is very carefully remove R209, just lift a leg up on it. So let's try to do that without destroying anything that we've already done. See, these are things that should have been done at the very beginning. But I've been so focused on trying to get the output that, so let's see if I can do it from this side. I think I did. So now no audio should be going to the audio amplifier. So we are going to go test this sucker. It didn't catch on fire. TV's on. I'm going to flip the switch. Absolutely nothing. So clearly my amplifier did not work. Clearly it did not work. I think I might be tapping out on this project here. Alright, it's been a couple days. I cannot figure out how to make an amplifier. I have pulled off Q201 to try to use that as an amplifier. I pulled off a transistor out of the RF module. It's a PNP. Tried to set it up like you saw in the last clip. It did not work. So what I'm going to do now is I am going to pull off my signals before they go through any type of resistors. I have my L1, L0, L1, L2, and my sync and chroma all tied together, and that's going to go to my video. And then I have audio I'm going to pull off at C208 right here. I'm going to pull that off. I've removed Q201, so there would be no amplification. And I've removed R209, so there's going to be no audio making it to pin 4 here. So anyhow, but I'm going to bypass all of that, and I'm going to come directly off of the TIA, which is located right here. And we are going to see if we get a signal and maybe some sound. All right, I've got power plugged in. Getting ready to cut it on. Holy cow! I can actually see picture. I don't have any sound, but I do see picture. Let me. Wow, that's crazy. That is absolutely crazy. Let me see if I can. Maybe the TV's turned down. Oh, you know what? I forgot to plug the stupid cable into the back of the TV. Be right back. All right, so it's a no-go on the sound. I am not sure why I don't have sound, but I'm pretty sure I pulled it from the right spot. I didn't. You know what though? I'm just happy I got video. So I'm gonna try to work out the sound issue. Ooh, I plugged it in. I did not get audio. I moved my audio wire to the top of the capacitor. Still did not get audio. So I put Q201 back in the circuit thinking maybe it's an amplification issue and maybe it needs Q201. So right now we're going to go ahead and cut this on and see what we get. Still no audio. Nothing. I don't know. I do not know. I think that I'm going to have to tap out on this audio issue. Because I mean, there's nowhere. I mean, there's no. Maybe I can put R209 back in the circuit and see what happens there. But yeah, I don't know. This is crazy. So on this episode of Probably Can't Fix It, I set out to fix an Atari 2600, and then I determined that the Atari 2600 was not broken. So I spent days learning about Luma, Chroma, trying to build an amplifier, and then it dawned on me: this Atari was broke. And it was the audio. That was the problem the whole time. And so, I mean, the only thing it could be is the TIA, because I've checked every other component and I'm getting voltages where I'm supposed to get voltage, but I'm not getting any signal at all directly out of the TIA. So I doubt very seriously I'm going to order a TIA just to fix this device. But I enjoyed learning. I learned a lot of things. So I hope you guys maybe learned something too.